righty. We should be able to get ourselves started here. Make sure I have everything that I need up here. All right, everybody, it is 12 noon according to my clock, and as everybody knows, who's ever attended these, I always start on time, being respectful to everybody who attended on time, as well as our presenters. You have found yourself in the CD Foundation's online meetup. We have these monthly. I'm so excited to have you here today. I am Tracy Reagan. I am the CEO and co-founder of Deploy Hub, and also the community director for an open source project called Ortelius that is being incubated at the CD Foundation. Like I said, we do these monthly. Last month was CDCon. I hope you guys all attended it. It was pretty awesome. I thought it was a really amazing conference, actually. I think all the speakers were spot on, and everything that the CD Foundation did for building out a true diverse community around the discussion of continuous delivery was they did a great job. Maybe next year we'll be doing it in person, but I do hope they keep it a hybrid event so everybody can be participating. Next month is August. We are going to take August off again. So we had June off, but we are going to take August off. It's a summer month and everybody's pretty busy. And we're going to kick off September. I'm hoping to have Walina Velasquez, I'm not sure how to say her last name. She is one of the primary contributors of the Jenkins project. I think she's on their Jenkins governance board. And I'm going to have her speak on how to get involved in an open source community. The CD Foundation itself is an open source community. We have special interest groups that you can get involved in. We have Spinnaker as an open source project, Jenkins, Ortelius, Screwdriver. We're looking at bringing on a few more in the upcoming year. So getting involved in giving back to the community that you are in is a kind of an important piece of this community. So we're going to have a discussion on how to get involved in an open source community and all the reasons why and how to do it. Today, we have Srini from OpsumX, and he is going to be having a discussion on something that's gotten pretty popular these days, which is, of course, GitOps. I was first introduced into the world of this kind of operator kind of format with infrastructure as code, and learning about operators day one, and from day one to day in operators, so spinning up infrastructure environments. That has started to come into even at the application level. So we're starting to have more of a discussion around GitOps. And I'm so happy today that Srini was willing to chat with us about GitOps and Spinnaker and how those two are going to be working together and what they call that style of DevOps will look like. Srini, I'm going to let you introduce yourself, but he is a DevOps architect. And I know there are others of you who have that title, and you know how hard it is right now to sort of keep track with where we're going with DevOps. So this is a great opportunity for you to ask questions, even bring up different topics around GitOps and GitOps with DevOps, because this is something that the OpsumX team are really, really focused on and thinking about. So please don't hesitate to ask questions. And you can just post them in the chat and I'll keep track of them. You can also post them in the Q&A. That works as well. So whichever place you want to put them, we will keep track of them. And on that, Srini, I am going to turn it over to you to go ahead and take us home.
All right, thanks, Tracy. I'm here to speak about GitOps style of DevOps with Spinnaker that we are spearheading here at OpsumX. And so let me get into it right away. So we are dedicated to making the process of continuous delivery easy and successful for everyone. We have a large number of customers of every size, from the most sophisticated, such as Salesforce and Cisco, to organizations who are now highly successful, even though they had little or no CD experience when they started with us. So let me dive straight into what is GitOps. So just want to start with a quick story I have here. At home, I have taken two laptops, one old and one relatively new, and made a small Kubernetes cluster out of them. This old laptop is kind of slow, but it's okay. I made it the master node. And the other newer one with a relatively higher memory is my worker node. So it's one master, one node Kubernetes system. And the thing is that this laptop with higher memory has this strange, interesting feature that it keeps crashing randomly. It crashes once, I think, a couple of days or something. And with this, normally the laptop would not be very useful. But guess what? In the Kubernetes model, I'm able to use it just fine. I have deployed applications and I do development on that. In the Kubernetes cluster, my workers, my pods are, of course, on this laptop that crashes every once in a while. And what actually happens when it crashes? Not much, really. I just have to reboot the laptop, and after a couple of minutes, everything comes back up. How is that possible? The thing is that Kubernetes stores all the pods, all the information in the cluster, in the HCD, which is, of course, on the slower laptop, which doesn't crash. So what happens is whenever the laptop crashes and I simply reboot it, the control plane, the Kubernetes control plane has this thing, a loop sort of thing that keeps going and checking if my target environment is in the state that I want it to be. And whenever it deviates from that, it simply brings it back up. So in a very simple model, this is what GitOps is. We have a declarative state of the system, and the system makes sure that the actual state of the application, and the environment, the system matches the state that we have declared. And this is what is GitOps. So using Git, it has version control built in, PR approval process built in. As your single source of truth, it gives you the ability to roll back to a previous unknown state, pinpoint the cause of failures, quickly deploy new services, and so on. Everything required to run an application, including the infrastructure, configuration code, everything should be version controlled. And this is really not a new concept. As Tracy pointed out, infrastructure as code has been there for some time. Manufacturing control process have been using this for some time. But the nature of software is kind of different. And we are going to look at how this GitOps model works in the context of software development and deployment. So what is GitOps? Fundamentally, there is a Git, which is a primary interface for all operations. There is automation that is convergent. It makes sure that the actual state, whenever it is different from the desired state, it goes ahead and syncs it with the Git. So Git stores the declarative state of the runtime, or what the runtime should be, and there is automation that ensures that the actual and the desired states are kept in sync. So there is an inherent feedback loop. So as I mentioned in Kubernetes, the control plane components keep pulling the kubectl. kubectl responds by telling the states of the pod and so on and so forth. And they initiate actions and events that will cause the cluster state to come back to wherever it was, even if we as much as reboot a node. And so we have version control, we have automation. Of course, there are a couple of models in here, push and pull model. Will not go too much into it. And this GitOps model is extraordinarily useful in organizations. They don't have a high ceremony process. and any approved changes are automatically applied to the system. So infrastructure code has been there around for quite some time. And we believe that GitOps is the next evolution of infrastructure as code. So why use GitOps? I guess at a very simple level, and I have been around in DevOps before DevOps existed. We used to call it system integration. We used to call it system build or release engineering and so on. There's so many names before DevOps came in. And the answer is actually very simple. Whatever is designed should be developed. Whatever is developed should be tested, and whatever is tested should be deployed. Very, very simple. While the answer is simple, the implementation gets rather tricky. And this is trickier when we have multiple parties involved. There are different teams. There's a development team, there's a testing team, and there's another set of people who approve it. Different environments, different criteria. For each of the environments, typically production environments will have a totally different criteria from other environments. So GitOps as a paradigm, in a way, is the enabler of the shift left that we talk about, where we are ensuring that the system reflects the changes and stays in sync with the desired state at a very simple level. What? Oops. All right. Tracy, just checking, am I still online?
You are. You froze up for a second, but you're good now.
All right, thank you. So having a single source of truth for infrastructure and applications also ensures that all the parties are collaborating. So it definitely promotes collaboration, and every dialogue, every change, every approval is automatically captured in Git. And this supports full auditability of the changes. And in customer environments such as banking, finance, and all, where auditability is a critical requirement, this would be certainly a welcome change. What is more, because we have a complete log of the changes, you are able to correlate changes that are happening in the runtime environment with whatever change happened, and that really helps in troubleshooting and root cause analysis. And the convergent automation that we talked about in the context of Kubernetes, it's ideally suited for environments that are constantly changing. And when you deploy faster and more often, the changes are not just in the code, but sometimes they're also in the configuration, the config maps, the secrets, and so on and so forth. And this adds to the overall dynamic to the change that's happening. So let's take a quick look at Spinnaker. Where does Spinnaker fit in all this? Spinnaker gives fantastic support for pipelines and automation. And the best part is that in Spinnaker, pipeline is essentially a JSON file. And we could take the JSON file and push it to a Git repo. And whenever I'm talking of Git, it need not be Git, it could be any repo. We in fact support S3 bucket as well, because Spinnaker supports AWS S3 buckets. So you have pipelines that are it's very convenient to check into Git repo and manage them as code. And Spinnaker also has configuration that is actually controlled through a set of pipelines. So it is possible to actually take the configuration of Spinnaker and kind of apply it to a running Spinnaker instance. We could take pipelines and apply it. So equivalent of simply take this pipeline and make it happen. And Spinnaker is really well suited for that. And the best part is that Spinnaker also plugs into the infrastructure. It shows you the current state of the infrastructure, and in certain cases can also create the server instances for deployment. Of course, not going to the details of Spinnaker, but you might be aware that it supports blue-green and canary deployments, automated rollbacks, and so on and so forth, all of which very nicely fit into the GitOps model. So just a quick overview as to what we have in a Spinnaker landscape. We have a developer who pushes code to GitHub. So as you can see, when you talk about GitOps, typically there is already a source code repository. Developers are comfortable using it. It's used across the landscape in organizations. And whenever the push happens, the pipeline triggers and automatically triggers, let's say, a Jenkins build. And the Jenkins build might also result in some automated testing. And then finally it goes to deployment, and then it gets deployed on the cluster. The example we have given is the Kubernetes cluster. And Spinnaker will go ahead and deploy it in the Kubernetes system. And typically this entire pipeline is orchestrated by Spinnaker. Spinnaker has an excellent pipeline orchestration system in place, and it plugs into all these other players in the system. So let's take a quick look at GitOps with Spinnaker. Deployment artifacts, which could be your deployment YAMLs, for example, or it could be Helm charts, or it could be images, Docker images, and so on. Spinnaker automatically handles artifacts from repos. So you can take a deployment YAML and store it in a Git repo and deploy it using Spinnaker. As I mentioned, when it comes to configuration, Spinnaker configuration can be stored in a repo and then simply applied. So there is something called as a Halyard pod, and Halyard is declarative. So we can simply take a configuration, irrespective of what the previous configuration was, and simply put it in there and ask Halyard, make it happen. And it'll ensure that the target configuration of Spinnaker matches whatever the configuration files you have specified, irrespective of what the previous state was. And that's really cool, because that fits in very nicely with our GitOps style of management.
Hey, Srini.
Yeah.
Can I ask a question?
Please.
I don't know if I've ever heard of Halyard. Is that an open source project, or is that something that is part of Spinnaker?
Oh, sorry, I should have mentioned that Halyard is part of Spinnaker.
Great. Okay, that's what I thought. Thank you.
Right. So let's take a quick look as to how this model can be further dive a bit deeper into it, how we are doing it with our customers, how it's done at OpsumX. We store the Spinnaker configuration in a Git repo. As I said, it need not be Git. It could be S3 or any of the other types of repository. And in Spinnaker, there are multiple. Spinnaker is a multi-microservices architecture-based application. And Halyard is one of the guys, the configuration agent, so to speak. and the Halyard pod configures the rest of the services. And what we have done is that we have changed the Halyard to include an init container. So every time it starts, it simply pulls the Git repo, places all the files. It also looks at secrets and injects them into these files so that Halyard can use those secrets and configure them. The secrets could be account passwords, Git tokens, and such. So this is because typically we don't want to have secrets stored in Git. Git may have access to many other people who we necessarily don't want to give, let's say, passwords to our database and so on and so forth. So the secrets typically might come from another source, let's say a Vault backend or ECR, or there are so many secret registries, secret stores from cloud providers, and those secrets are injected when we put that in. And customers typically like to have a separate Spinnaker for production than for rest of the environments. So we could use the same Git repo and have different branches for different instances of Spinnaker if we have. And then we also have another repo. It could be the same repo for the purpose of depiction. I have shown it as a different repo, which stores the pipelines. And Spinnaker, as I said, a pipeline is nothing but a JSON file, very convenient. It's a text file. It can be checked in. It can be pushed to the Git repo. And Spinnaker also provides a command line interface that we call SpinCLI. And we have some custom stages that will automatically sync the pipelines from the Git repo into Spinnaker. So what it does is that it also gives us an opportunity to do some minor editing of the pipelines. For example, we could ensure that the pipelines are not editable in the UI. We could change the account names or something for different environments, and so on and so forth. So some editing or modification to the pipelines is possible as the pipelines are being pulled from the Git and applied into the system. Because Spinnaker has built-in triggers for Git and, of course, many other sources. So whenever we make changes to, let's say, a pipeline in a Git repo, it could be automatically be applied. So if you configure the Spinnaker correctly, configuration changes could be many. Sometimes we have to increase the memory or the CPU limits of different Spinnaker pods. Maybe we want to add additional accounts. Very frequent is changing passwords, and so on and so forth. All these changes, we don't actually have to go and do it on the system. That we do it in the repo, which gives us, again, this entire model of approvals, audit, and so on and so forth. So whenever we want to add new applications or we want to roll back a pipeline to a previous state, make changes to config maps, secrets, and so on, everything is done from Git repos. So a config map, secrets, and other things we can store in a Git repo, like an artifact repo. And the pipelines, when they execute, they take the artifacts from the Git repo and apply it to the target deployment environment. So this gives us the ability to make sure that we have a central source of truth where everything is stored, everybody can look at it, different parties can collaborate, and yet the secrets are not there. We don't have to expose the secrets. And the secrets may actually be different for different environments. So a production Spinnaker, for example, may have a different set of secrets, and they get automatically applied with the same configuration. And this is the model where we are also using promoting of pipelines. And what is pipeline promotion? Whenever we want to make a change in a pipeline that is deploying to production, let's say, obviously we don't want to try it out there. We need to try it somewhere, maybe in a stage or a QA environment. So we test it over there. And once we have tested, we want to ensure that the same change is applied to the production pipeline. Now, how do we do that? It is actually possible to have a non-production Spinnaker pipeline be exported, so to speak, and imported into a Git repo for the production pipeline, making absolutely 100% sure there's exactly the same pipeline that's running in production that was tested in staging or dev or wherever in the non-production environment. And this concept basically is very, very simple to implement in the same model. If we have different Spinnakers for production and non-production, where we basically just have different branches within the same repo. So let's take a quick look at what are the gaps in the overall GitOps model we spoke about, where we started with looking at Kubernetes as an example. And very frankly, a lot of the GitOps model is driven by the success of Kubernetes and the model, the design model of Kubernetes. So what are the gaps? Of course, there are gaps associated with cultural and technological hurdles. At the same time, uncontrolled changes to environments, somebody going and making some product change to a production server and so on, needs to be prevented. And organizations are looking at how to do that. How do we prevent uncontrolled, unauthorized changes to the production environment? And GitOps is a step in that direction. A lot more needs to be done. And some of the reasons why GitOps is still not the mainstream is because it's needs to mature. The tools need to mature. And there clearly we lack established patterns because the whole model is fairly new. And scaling can become complex. How does the promotion to different environments work? And the number of repositories quickly skyrockets. We recently took up a task of deleting the number of GitOps repos that were no longer in use. So we actually had to spend some time looking at all the repos, identify which are in use and which are not, because the number of repos is pretty large. And then, of course, there's an underlying expectation that the different parts of the organization are tuned to the Git interfaces. And the way we look at it is that this may be very, very early stages of what would have been the case with, let's say, databases or any of the other technologies where they're used ubiquitously in companies. So in good old days, there were very few people who knew about databases, knew how to extract data using SQLs and so on, no UI, and the rest of the organization is dependent on this. So we are somewhere there, maybe not at such an early stage, but the fact still remains that we don't have all the tools needed to make the GitOps work. Of course, we also have process challenges. Git only gives you a central repository, the single source of truth, but we still need a lot of processes, the equivalent of the Kubernetes control plane, if I may say so, because the processes are different. Let's say for production, the configuration may be different, and so on and so forth. And as I said, a deployment YAML is somewhere, there's a template, and the template gets configuration substituted. So how do you see what is the final state of the config map? We have to go to the system and see. So we probably need tools there. And when we say that convergent automation or automation that is convergent, this does take a lot of tools. And even if you see something like Terraform, that's infrastructure as code, it does have loops, it does have some logic, which is imperative, and it does break sometimes. So this entire GitOps model still needs to evolve. And then we have the whole issue around visibility, because now we have a single source of truth, and we need to see what is happening in the system. So we'll need a lot of tools to provide the visibility as to what is happening in the environment, because clearly the feedback loop in many cases, including Spinnaker, is lacking. On one side, Spinnaker is able to create server instances, is able to show what is there in the infrastructure, the actual state, but it still does not have a control system or loop to bring it back to the desired state. So certain tooling is still required, and this entire GitOps model will mature as time progresses. So just wanted to show you some resources, and you're welcome to go to our site and take a look. And at OpsMX, we are working on the tooling that will further support GitOps, and also this whole model of high-speed deployment, which requires that we have some sort of a verification. So we have a machine learning-based algorithms that do the verification. We have policy. This is what Tracy and I were talking before we started, that we have policy integration that allows pipelines to ensure that there's a policy in place. So for example, what we talked about, GitOps, same thing, installing, we're deploying something to a dev environment, the policies may be different, whereas in production, we want to have a totally different set of policies. And then we are also working towards visibility, providing higher visibility into the different moving components in the system. And the tooling that is that needs to go around the entire GitOps style of running DevOps using Spinnaker. So this is roughly the end of my presentation.
Srini, thank you so much. This is a fascinating conversation, really. When I first started talking to my peers on this topic of GitOps, I would say, I have a problem with seeing how GitOps will scale. I know it can, in terms of the architecture side. You can have as many operators running as you want in every cluster, and it can scale fine that direction. But getting us to that point is where the scaling issues are. And I think that you've addressed some of those. And I like to call it the human side of GitOps or the front end of GitOps. But that's where we need to solve the problems for GitOps now. Because if you think about how many potential YAML files we're going to have in a microservices environment, if they're truly being shared and deployed independently, there's a lot. And automating some of the front end of GitOps, I think, will be critical in particular for integrating it into a DevOps pipeline. So I think it looks like Spinnaker and the OpsMX team is really thinking about how to solve these front end problems. And on that, I want to let everybody know I've invited you to talk. So if you have a question, there's just, please just don't be shy. just ask the question, and that way we get it recorded. So anybody who's watching this on a recorded, which is the majority of our viewers, they can hear your questions. So please, if there's a question about GitOps or any aspect of what Srini covered, just go ahead and put it out there. And to get people thinking, Srini, what are your thoughts on how this is going to look in a microservice environment where we have so many moving parts?
Yeah, so as you correctly pointed out, when things are simple, you have 1 or 2 pipelines, 2, 3 deployments, it looks all nice. But it's when you have a microservices based application with, let's say, 100 different microservices. This is what we are working with one of our customers. Things can get very tricky. How do we know that all the 100 applications, I mean, the source code related stuff, the configuration related stuff, and everything has moved nicely between dev, staging, QA, and production? So that this company actually had teams of people just going and verifying that everything is right before it goes live. And once we have move towards GitOps style, the configuration control comes built in, so we can be sure that at least the same stuff is being moved across environments. And what it lacks, though, is the control, the system, the feedback, the equivalent of the control plane, so to speak, of Kubernetes, where we can actually go and check if somebody modified, let's say, a config map manually in production. The system automatically corrects it and puts it back to where it should have been from Git. So that part is of the tooling is still, further ahead the road.
Right. And we get a question out here. How does it compare with something like Flux CD? Maybe you can explain what the Flux operator is.
Very frankly, I'm not aware of that, so I'd say pass.
So I can give a, so we're looking at 2 sides of this puzzle here. When you think about things like Flux, that is the operator itself. Now I don't know if Flux CD is starting to build out a DevOps kind of solution around it, but Flux is primarily that operator, and Spinnaker would be integrating. Spinnaker doesn't care if there's what operator you're using, I don't believe. It's just making sure that the correct YAML file is being pushed into the repository. So, there's things like Flux, Rancher has an operator. I can't think of the name of it at this moment. Terraform has an operator. It lives outside of a cluster. So when you think about GitOps, you have to think about the 2 sides. You have to think about the CD pipeline side, and you have to think about the operator side. Flux is primarily an operator. I don't know if there's something called Flux CD that is like Argo CD. I'm assuming that all of these operators are going to put some kind of a front end on those their tools, so that you have better insights in terms of what it's doing. But I don't think Flux is pushing a full CD pipeline, but I could be wrong. I am happy to be corrected on that. Any other questions for Srini while we have him? There's a question about, says, does Spinnaker support Bitbucket Stash?
Yes, it does. So we support pretty much all different forms of Git, GitLab, GitHub, Bitbucket, Bitbucket Stash, which is I think it's called Bitbucket Server now, the on-prem version, Bitbucket Cloud. Yeah, all basically anything that has support for the Git CLI.
Yeah, and I think that's an important question, because we oftentimes think of GitHub, but there are other repository tools out there, aren't there?
Yeah, GitLab is there, and Bitbucket is there, and so on. But we are using Git as the GitHub
Yeah.
as a default name for GitHub, GitLab, and so on.
Anybody else? Well, that means we'll be stopping about 5 minutes early. I usually try to keep these to about 45 minutes because it makes it a much more pleasant experience when you're watching it from a recorded point of view. So Srini, thank you so very much for your time today and for your insights into GitOps. I don't think this will be the last session we'll have on GitOps. I think this is one of the, we did have Argo CD last year, but I think that the interest in this area continues to climb, and it will be an interesting conversation moving forward. And I just want to make a plug for the CNCF does have a GitOps SIG. If anybody is really interested in learning more about GitOps or getting involved in the conversation, you should check out the CNCF GitHub repository, look for the GitOps SIG, and all that information will be there. And on that, I will call this meeting to an end, and thank you so much for everyone. This will get published and posted up to the CDF's online meetup YouTube channel. So if you'd like to share it with your comrades, that will be a good place to do it. And I should have it up there by tomorrow. And I will send a message out to the full meetup group, letting everybody know where that link is. All right, Srini, have a fabulous day, and thank you so much for your time. We sure appreciate it.
Thanks, Tracy, for the opportunity. I really appreciate it.
My pleasure.